right, hello everybody. So we're going to get into scientific notation and then see how it relates to the standard form of a number. So some things we'll be able to do is express numbers in scientific notation. And then one of the big things is we'll be able to convert numbers back into standard form as well. Okay, so let's think about what is this whole deal with scientific notation? What does it mean? Why do we need it? And then we'll talk about how do we work with it. All right, so here's kind of a couple examples of just some real life situations here. So if we think about situation one here, the distance from Earth to the sun is about 93 million miles. So 93 and then a million is going to be 1, 2, 3, 4, 5, 6 zeros, right? So 93 million miles. It's a pretty big number. Scientific notation, we'll see, is going to give us a shortcut way of writing numbers like this. Now, this wasn't even too crazy, but just imagine if we wanted to know, like, for some crazy reason, how many inches is it from the Earth to the sun, right? And we'd have to multiply by, how many feet are in a mile and how many inches are in each foot and all that stuff, and you'd get like a really huge number of inches, right, to get to the sun from the Earth. So scientific notation is going to provide us a way of writing that in a shorter notation. Okay, or on the other side of the spectrum here, the mass of a dust particle is approximately 0.00000000753 kilograms. Right, so a really small number. Sometimes it's hard to picture, like how small of a number is that? Okay, I mean we can see all the 0.0000000 but I mean how would you want to write that over and over, or is there a better way? Okay, and scientific notation actually is the better way. So let's get into it and let's see how it works. All right, so let's think about first off a couple background things. Scientific notation is going to involve using 10 to different powers. Okay, so for example, 10 to the first power we know just means it equals 10. 10 to the second power, of course, is 10 times itself, right? So that's going to equal 100. 10 to the third power is 10 times 10 times 10, okay, which equals 1,000. Okay, and the cool thing is when you multiply by 10 or by 100 or by 1,000, you might recall that you can just simply move the decimal on the number, and it's an easy way to get the answer. So for example, if we wanted to do 6 times 10 to the third power, it would be 6 times, so 10 to the third power is 1,000. Okay. Notice also while I'm doing this, the exponent on 10 is going to be the same as how many zeros there are in the value. Okay. So that's a little trick. And then, like I said, 6 times 1,000 we know is 6,000. So what shortcut that we could be using is, think about when you take 6. Okay, that's the number 6. It's really like 6 with a decimal point right there, right? 6.0 is equal to 6. If you were to just take a look at this exponent, it's telling you how many times you need to move that decimal place. 1, 2, 3, and the decimal would now be there, and we fill in the little gaps there with zeros, and that's how we end up with the answer of 6,000. Okay, and we can do the same thing with the example on the bottom there, 4.5. As written, 4.5, the decimal was already a decimal in there. The previous example showed you move the decimal point however many times that is equal to that exponent on 10. So I'm going to take the decimal that was right here, and I'm going to move it 5 times. So 1, 2, 3, 4, 5, and it would now be here, and we just need to fill in all those placeholders with zeros. So our answer would be 45 with what? 1, 2, 3, 4 zeros? Okay, which would be 450,000. Okay, so let's keep going on that and kind of see if we can keep working with this a little bit more. Okay, here's a couple more examples I'd like to try. Let's see if we can find the value of these expressions. So 15 times 10 to the third power. Okay, so 15 right now, there's a decimal point right after the 5 there. It's 15.0. If I were to move the decimal point 3 places to the right, 1, 2, 3, and it's now here, and I fill zeros in, Okay, we should be able to see the answer is now 15,000. Okay, how about 2 times 10 to the 6th power? So 2 right now has the decimal, of course, right after the 2. It's 2.0. We're going to move the decimal 6 places to the right. 1, 2, 3, 4, 5, 6. The decimal is now there, so that means I'm going to have 6 zeros. 1, 2, 3, 4, 5, 6. Okay, so our answer here, that would be 2 million. Right? Times 10 to the 6th lets you know you are in millions. One last one, 43.2. Okay, the decimal's in between the 3 and the 2 right now. If I wanted to multiply that by times 10 to the 3rd, I'm going to move the decimal 3 places to the right. 1, 2, 3. It's now going to be there. We will have zeros there and there. So our final answer would be 43,200. Okay, and these are getting close to scientific notation. There's one kind of trick with scientific notation. The only one that's correctly written in scientific notation actually is, anyone know? Anyone know? Okay, this one, part B, was in scientific notation. We're going to see there's going to be a rule that the thing that you're multiplying by 10 to some power, whatever this number is, must be a number between 0 and 10. Okay, so let's take a look at a couple more examples and see how this works. All right, and one thing I just want to clarify, I just said the number needs to be between 0 and 10. It technically needs to be between 1, greater than or equal to 1 and less than 10. Okay, so let's take a look at some examples. Let's do it. So here's a worked out example. The diameter of the sun is 1.39 times 10 to the 9th power. Okay, so this is scientific notation because, again, it's some a value which is between 1 and 10. Okay, so 1.39 times 10 to the 9th. So what we're going to do is we're just going to do the way we did it, and we'll just verify that we get the same answer. So it's 1.39, and we need to be moving our decimal point because we're multiplying by 10 to the 9th power. So we're going to move it to the right 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4, 5, 6, 7. So we will have 7 zeros. And if you see our number right there matches up, it's 139 and then 7 zeros. So that would be 1,390,000,000. All right. So let's take a look now. Let's do some more. Can we rewrite a few more values? Let's just do maybe 2 more of these. I think we've done a lot of practice here. They want you to write these in standard form. So 4.3 times 10 to the 7th power, 4.3. Again, times 10 to the 7th means 7 times. We're moving the decimal. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6 zeros there. Okay, so that's how you get the big numbers. You multiply by 10 to a power. Imagine writing something like that. That's kind of mean of them to make you give such a big value. All right, but anyways, let's see if we can do this backwards. Okay, can we convert 25 billion from standard form into scientific notation? Okay, so here's the trick. We want to identify the location of the decimal point first. Okay, we know 25 billion has a decimal point at the end. Okay, we need to figure out what is the number that we're going to multiply times 10 to a power. So remember, that number needs to be between 1 and 10. So I need to figure out how many times am I moving the decimal to get it to be right in between the 2 and the 5. I want it to be 2.5 times 10 to some power. So we just kind of have to count it back. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 times, right? If our a value is 2.5 and we multiply it times 10 to the 10th power, that would move it all the way back to where it needs to be here. So that should be our answer. Okay, so we're really just kind of counting how many decimal places did we have to move that decimal. Okay, let's try a couple others. All right, so can we convert 6,000 back to scientific notation? So again, think about what's the number between 1 and 10, In this case, it would need to be 6 times what, 10 to what power? So if the decimal point were there, we would move it 1, 2, 3 times. Okay, part B, looking at this number, I know it's going to need to, the base or the initial value is going to be 4.36. So the decimal point would be there, and we would move it 1, 2, 3, 4, 5, 6, 7, 8 times. Okay, try one more. 16,000. So I need my number to be 1.6, because that's the number between 1 and 10, times 10 to the, we moved it 1, 2, 3, 4 times. 4 times. Okay, so you see in the first example, we kind of counted backwards to see where it would end up. This time I just kind of placed the decimal in the appropriate place to make this number be between 1 and 10, and then I counted how many times it had moved to get up to the actual starting point. All right, so let's take a little bit longer look at a couple more examples. Let's see if we can get this table filled in with just different representations. So you see in the first one, it's 7.4 quadrillion. Okay, so it's actually a word, quadrillion. So it's 7.4 times 10 to the 15th. In the first row, or the second row, I guess, if we have 3 times 10 to the third, so that would mean we're starting out with 3, and we're moving the decimal point 3 times to the right. So it was here, go 1, 2, 3. So that number would be 3,000, right? 3,000. All right, next row down, they're giving us a value in standard form. I want to see, how would we write that in scientific notation? So if the decimal point is right there, it's going to be 1.2 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 1.2 times 10 to the 9th power. That's going to be 1.2. 10 to the 9th is billion. All right, next row, 5 trillion. Let's take a look. Let's see what they got, some information up here for us. They're getting some big numbers in here. Here's some common, or some not so common, but 1,000, then million has 6 zeros, billion has 9 zeros. Trillion actually has 12 zeros. Okay, and then there's quadrillion, there's quintillion, sextillion, septillion, octillion. You get down to a Google down there, which is 10 to the 100th power. So we just wouldn't be able to write 100 zeros. It's just not enough space in there. But these are actually real numbers, right? You can actually use these. So let's think about, we need, for our problem, was 5 trillion, right? So trillion, again, is the one that's going to have 12 zeros after it. Okay, a 1 with 12 zeros. So 5 trillion is going to be a 5 with 12 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Big, big, big number, right? So to get that into scientific notation, if it's just a 5 and then 12 zeros, 5 times 10 to the 12th power. Okay, big, big number. All right, then the next one, standard form, 9 with 6 zeros, that is 9 million. And if we want to think about the decimal being, if it was 9 and we moved the decimal 1, 2, 3, 4, 5, 6 times, right, it would end up being 9 times 10 to the 6th power. All right, let's see if we want to do some estimating, right? Let's say, so according to the U.S. Census, the population of California in the year 2010 was 37,253,956. So let's write an estimate using scientific notation. So what we're going to do, we're going to first round this, okay? If we're just getting an estimate, we're going to round the 37 million. Since the greatest place value is in tens of millions, let's round that to the 40 million. Okay, and that way when we write it in scientific notation, we're not going to have to do 3.7253. We can just treat this number as 40 million, and we can just think of that as, in scientific notation, if we think about where the decimal would have been, if this was a number between 1 and 10, it would be right there, 4.0, or just 4 times 1, 2, 3, 4, 5, 6, 7, right? So times 10 always to the 7th power. Okay, so that would get you an estimate of 40 million. Okay, and I think that example's finishing up here. Yeah, so why don't we just do one more of these? Can we write an estimate? If we do the try these. So part A, 284,116. So if we're just estimating, okay, again, the largest place value here is, this is the 2 for the 100,000s place. And since it's 284, we're going to round that, using a little squiggle for approximate, to 300,000. Okay, that's rounding it to the nearest 100,000. And that just makes it easier for us to use 3 as the number, times, and then we're going to do 10 to the, what power are we? If it's 3 is right there, we go 1, 2, 3, 4, 5. Okay, 3 times 10 to the 5th. All right, why don't we just do the one last one just to feel like we completed everything. So part B, 5,218,996. So the million spot is the largest place value. So since it's 5 and then a 2 next, we'll just round this down to 5 million. Okay, and that's going to mean it's going to be 5 times. Now if the decimal was right after the 5, we would be going 1, 2, 3, 4, 5, 6 times. So 5 times 10 to the 6th power. Okay, so that's scientific notation. It really helps you write really large numbers in a much quicker way. It can also be used to write really small numbers in a quick way as well. All right.